gentlemen, this is 9.3 Pythagorean Theorem, and there's a couple key points we need to make sure that we're getting in this video. And one is that the hypotenuse is the opposite side of the right angle. So it's the side opposite of the right angle. So you see the hypotenuse is this longest side, and it's opposite of the right angle. So it is opposite of that right angle. Also need to know it's the longest, and I'm writing this in all caps. And this is going to be helpful later when we're looking at three sides and we don't know which side is which. But if we know the longest is always the hypotenuse, then we'll be able to problem solve pretty easily. The other things we need to know that the legs are the sides that touch the right angle. So they come together and they form that right angle. They are related to each other. The legs are related to the hypotenuse through the Pythagorean theorem, and we're going to look at that very closely this chapter. Okay, the formal definition for Pythagorean: for any right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So these are my legs, A and B, and my hypotenuse is C. It is saying that if I square A and I add that to B squared, so I need to square the leg also, so both legs get squared, then it is going to equal my hypotenuse squared. This is a formula that you're going to need to know. Most of you may already have heard of it, but it's A squared plus B squared equals C squared, and we're going to learn how to use this to solve for right triangles. Okay, ladies and gentlemen, make sure you're pausing as you need to take down the notes. This is going to be us actually applying the Pythagorean theorem. So we have A squared plus B squared equals C squared. I'm going to tell you that it really doesn't matter. I can call either leg A, or I can call it, I wish I could write, B. Same here, I can call this one A, or I could call this one B. So let's look at this. Okay, so we can call either these A or B. The legs don't really matter unless I'm told specifically which one to assign. So I decided to go ahead and use 20 as my A, and I'm going to use B for 21 because I'm going to be adding these. And remember, order doesn't matter. So whether I add B to A or A to B, I'm still going to get the same answer. So if A equals 20 and B equals 21, then I'm going to plug in 20 where I see A, 21 where I see B, and I don't know C. So I get 20 squared plus 21 squared is going to equal C squared. So I square them, and I get 400 plus 441 equals C squared. And I add those, I get 841 equals C squared. Please notice this says C squared, this says C squared, and this says C squared. I have left this as C squared. Now I want to find out what 1C is, so to find the opposite of, or do the inverse of C squared would be to take the square root of C squared. And if I take the square root of one side, I've got to do it to both sides. So I'm going to take the square root of 841, and I'm going to take the square root of C squared. Well, square root of C squared is C, and then I find 841, the square root is 29. My answer is C. 29 for C. So I know that this one is 29 units, whatever the units would be that I'm working with in this lesson. We have another application problem. Kyle's building a triangular model of a mountain for the scenery of a play. We're going to find the length of the base. This is going to be our C. How do we know that? There is the right triangle, and it is opposite of the right triangle, so I know this is my hypotenuse. Even though it's X, just for the formula, we can refer to it as C. So I know each of my legs is 10. So I'm going to substitute 10 in for A and 10 in for B. And then I'm going to square. So 10 squared plus 10 squared is 100 plus 100. It's still going to equal C squared. Adding 100 plus 100, I got 200. I kind of skipped that step there. Equals C squared. I want to find what 1C is. So I need to take the square root of C squared. If I do that to one side, I have to do it to the other. And I get a decimal. I get 14.14, and it continued. I took it to the hundredths place. And then it asked for me to find to the nearest foot. So the base of the model is approximately 14 feet. So a couple things to be aware of is the c squared doesn't change. You have to leave that. The only way to undo that is to take the square root. If I take a square root on one side, I got to take it of both sides.